Yo, 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 yo. Hey everyone, this is the first official video of 1.1 in terms of what's actually in the 8th grade book and what's our 8th grade material. So this is the start of somewhat new material. So first what we're going to do is we are going to rewrite rational numbers. So that's for part 1. There's actually 3 parts to this section. So key terms, we have terminating decimal and repeating decimal. A terminating decimal has a finite number of digits. It comes to an end, like 0.5. Repeating is one that goes on forever. A common repeating decimal like 0.3 repeating, because that's just 1/3. So 1/3 is 0.3 repeating, and so we'd use this line to show that it's repeating, which means it keeps going and going and going, and it'll never, ever, ever stop. So first what we're going to do, though, is we are going to write fractions as decimals, or we're also going to go from decimals to fractions. So the way we go from a fraction to a decimal is, well, hopefully we might have an idea of how to do this, because we should know that every single fraction is just a way to represent a division problem. So when we show division, we show it with fractions. So if I wanted to do, let's just say off to the top of my head, if I said, let's figure out what 32 divided by 4 was. Well, 32 divided by 4 is 8. But another way to write 32 divided by 4 would be 32 divided by 4. These are the same exact thing. They mean the same thing. This right here, this fraction line, is the same thing as this divided by sign. So this is 32 divided by 4, which is 8. So this right here is 1 divided by 4. Now, 1 divided by 4, though, if just to show the process, let's show this for this first one. You do not need to do this every time, but it's nice to have this in our notes so we see how to set it up. This is the same thing as 1 divided by 4. And 1 divided by 4 is the same thing as 1 divided by 4. Notice what number goes inside the house. A lot of times we like to put the larger number inside. So a lot of people would do 4 inside, 1 on the outside, but that's not the case. The top dog always goes inside the house. And the bottom one would come over here to the outside. So 1 over 4 is really just 1 divided by 4, which is really 1 divided by 4. And then from here, you would actually just have to do some division. So this is where I look at it. Does 4 go into 1? Well, no, it doesn't, so I'm going to put a 0 up here. So now this is where I got to make the decision. Well, what do I do next? Well, I don't have any numbers, so I can add a decimal and a 0 and bring that decimal up, because 1.0 is the same thing as 1. 4 goes into 10 twice. Take away 8. I'm left with 2. I still have to keep going because I still have this remainder down here, so I got to keep going. So what I'm going to do is I'm going to add another 0 and just bring it down. 4 goes into 20. 5 times. 4 times 5 is 20. So 1/4 as a decimal is 0.25. That is a terminating decimal because it comes to an end. And that's the whole process here. Let's look at another one. So 1/3, I know the top dog gets the house and 1 on top. So this is going to be 1 divided by 3. So 1 divided by 3, 3 goes into 1, 0 times, add my decimal, and a 0. 3 goes into 10, 3 times, because 3 times 3 is 9. I just realized I gave you the answer to this one on the last one, but the good thing is we'll show how we get there. So when I subtracted 9 from 10, I got 1, and I had to bring down another 0 because I have this remainder. But if we look here, didn't I just do 3 goes into 10? Because we're going to keep getting the exact same thing. 3 goes into 10 3 times. I'm going to subtract 9. I'm going to get 1 and bring down another. I'm going to have 10 every single time. That's when we have a repeating decimal, when the pattern's going to repeat continuously. So 1/3 is just 0.3, and the 3 repeats. I guess I should have written that over here, huh? That makes more sense. Easier to see. Okay. So that's how we go from fractions to decimals. We just divide. Now, to go from a decimal to a fraction, decimal to a fraction actually is kind of nice. whenever we have a terminating decimal, we want to change it to a fraction, count how many numbers we have. 1, 2, 3 numbers. So after the decimal. So we're counting how many numbers are after the decimal. And then what we do is we put that number in the numerator. So whatever's after the decimal goes in the numerator. So 0.825. So that means I'm going to have 825 in my numerator, and the amount of numbers I have is how many zeros I have in the denominator, but we got to throw a 1 in front. So that's 825 thousandths. So we can start off like that, but really this zero will eventually, this zero goes away. The zero and the decimal go away. That was the whole point of this. So because there's 1, 2, 3 numbers after the decimal, I have 1, 2, 3 zeros in my denominator with the 1 in front. So it's 825 thousandths. And then from here, we do need to simplify by dividing by the common factor. I'm going to divide by 25 because I know that 25 goes into 1,000, and I know it goes in 825 because it ends in 25. So I'm kind of lucky with the fact that I get to, it's an easy one to find a big common factor. 1,000 divided by 25 is 40. 825 divided by 25, let's see, that's going to be 33. And there's my fraction in simplest form. Now with repeating decimals, it's a little different. Instead of placing it over 1,000, so because there are 3 numbers after the decimal, I had 3 zeros. Repeating decimals, it's the same process, but instead of using 10, 100, 1,000, we're using zeros. We're actually using 9s instead, because repeating decimals are a unique situation. So because there's 1, 2 numbers after the decimal, I'm going to have 37 over, instead of 100, it's going to be 37 over 2 9s, 99. And I can just stop there because that cannot be simplified. So repeating decimals, we just throw 9s under there instead of zeros. Okay? All right, so please try to change these fractions into decimals. See how you do, get some practice in here, and then unpause and check your work. So pause it now, change them to decimals, and then check your work. Okay, 5/11ths. That's 5 divided by 11. 5 goes inside the house because it's the top number. So then you actually have to just do your division. 11 goes into 50. 4 times, subtract 44. I'm left with 6. Bring down my 0. 11 goes into 60. 5 times. 55. I'm left with 5. Notice how we're exactly where we started. Because right now, I started with 11 goes into 50 4 times. And then I went to 60, and then now I'm back at 50. So that means I'm going to repeat this pattern. So 5/11 is 0.45. And the whole thing repeats because then it's going to go 4, 5, 4, 5, 4, 5, 4, 5, 4, 5. Okay? How about this? What I'm going to do is I'm just going to skip ahead. I'll work this out so that it all just pops up for you so you can check your next 2. Okay, here are the last 2 for you. So for number 2, you should have had 0.125. There's your division work. So if you didn't quite get that, check your work and see how it matches mine, and then we can see where we went wrong. Now for number 3, it's a mixed number, but that doesn't change the process. If it's 2 1/3, I know my decimal has to be 2 point whatever that 1/3 is. So there's no reason to change this to an improper fraction. You always could, but it's just a waste of a step. Because this has got to be 2 point something because it's 2 1/3. So it's going to be 2 and whatever the decimal is. So really I just had to change 1/3 into a decimal. I showed the work, but we all should have known that that was 0.3 repeating because we just did that problem. So that would be 2.3 and the 3 is repeating. Okay, so now pause and try these 3. Change your decimals to fractions. And then from here, what I want you to do is once you change your decimal to a fraction, try to simplify. And bam, there's your answers. So the first one, number 4, you should have 3/25. 2 numbers after the decimal means I have 2 zeros in my denominator. That's why it's 12/100. which then would simplify to 3 over 25. Maybe you divide it by 2 twice. That's fine, but eventually you would have gotten to 3 over 25. 57 repeating. So because it's repeating, I have to use nines instead of tens, hundreds, thousands. So 2 numbers after the decimal, 2 nines. So it becomes 57 over 99. If you stopped here, that's understandable. It's hard to see that 57 can be divided by 3, but it can be, and it's 19. So it should have been 19 over 33. But if you stopped here, that's good work. That means you know what you're doing. Finally, I have a number in front of the decimal. Doesn't change the process. This is going to be 1 and whatever the fraction is. So I'm really just looking at the 0.4, and I'm putting the 1 up in the front. So 0.4 is 4/10, 1 number after the decimal, 1 0 on my denominator, and then I could have simplified that to 2/5. So that's why it's 1 and 2/5. And that's all we got for you guys. So things to remember, the fraction bar does mean divided by. Okay, so that's a big thing with fractions. Also, I want you to add to this. Use nines for repeating decimal. And that's when we're going from a decimal to a fraction. Okay, you have 3 problems for independent practice. You have to finish those 3 problems for your independent practice in order to get full credit for these notes. That's all I got for you guys. I hope you guys don't have any questions. If you guys have any questions, please don't hesitate to ask. Let me know. And thanks for watching. Gradius is out.